For years, AI had basically one direction it was moving in. Bigger, more powerful, more centralized. You train a giant model, you run it on a giant cluster of GPUs, and then you bill someone for the privilege of using it over the internet. That was the whole playbook, and Nvidia, almost by accident, became the first company that made it all possible. The results speak for themselves. GPT-5, Gemini, Llama, all the models that genuinely changed how people work and think. None of that happens without massive data centers filled with Nvidia hardware. So I'm not here to trash the model. It worked. It still works, but something is starting to crack, and it has nothing to do with software or algorithms. It's a much simpler problem. Physical infrastructure is hitting its limits. Power grids, land cooling capacity in several US regions, new data centers projects are already being delayed because the local utilities simply cannot supply enough electricity. You can have the best chips in the world sitting in a warehouse, and none of it matters if there's no power to run them. A single modern AI server consumes between 5 and 10 kilowatts of electricity. Scale that to a rack and you're at 20 to 30 kilowatts. Scale that to a fully hyperscale facility and you're looking at hundreds of megawatts. Globally, data centers already burn through somewhere between 400 and 500 terawatt hours of electricity per year, and projections say that that number could exceed 1,000 terawatt hours before 2030. That's more than a lot of countries use in total. So the industry is at this weird inflection point where the appetite for AI is growing faster than the infrastructure can realistically keep up with, and that gap is what's making edge AI so much more relevant right now than most people realize. Now, before we get into the edge AI, I want to point out to something that I think gets glossed over constantly. The biggest energy cost in AI is not the computation itself, it's moving data around. In modern AI systems, transferring information between memory and compute units can account for 80 to 90% of total energy consumption in some workloads. You have chips doing billions of operations per second, and most of the electricity bill isn't even going to the math. It's going to the act of feeding the chip data and pulling results back out. And here's the brutal part. As models get bigger, the amount of data that has to move around grows even faster than the efficiency of hardware does. So the problem is self-reinforcing. Bigger model means more data movement, means more energy, which means more infrastructure pressure, and that eventually means you run into a wall. This is really the structure issue underneath the whole Nvidia versus edge AI conversation. It's not really about one company versus another. It's about the physics of whether computation happens and whether centralizing everything in massive data centers is still the smartest way to do this. Now, edge AI means running AI workloads locally on the device that generates the data instead of shipping that data somewhere else to be processed. The device could be your phone, a camera in a factory, a sensor on a bridge, a car, a medical monitor, anything. The power difference is pretty wild when you see the numbers side by side. A high-end data center GPU pulls somewhere between 400 and 700 watts. An edge AI chip typically runs between 1 and 10 watts. Some of them are below 1 watt. So you're looking at power consumption that is literally hundreds of times lower. And the latency story is just as compelling. Instead of sending data across a network waiting for a cloud server to process it and then sending a response back, everything happens locally and almost instantly. For a lot of real-world applications, this is not a nice to have. It's a hard requirement. Think about a self-driving car. The car detects something in the road and needs to brake. You cannot wait 200 milliseconds for a round trip to a server. That decision has to happen on the car in real time with no network dependency. Same thing in industrial automation, in robotic surgery, or in any situation where the cost of delay is measured in physical consequences rather than just the user experience. Now, what I find genuinely interesting about the edge AI space is that it's not just Nvidia in a smaller box. It's a completely different hardware philosophy, and it's attracting a totally different ecosystem of companies. Qualcomm is probably the most aggressive player right now. They acquired Edge Impulse in March 2025, bringing in over 170,000 developers who built edge AI models, and their Snapdragon X2 Elite delivers between 50 and 85 TOPS within a 15-watt power budget. That's serious on-device AI performance. They've also partnered with Foxconn to deploy AI edge gateways across smart manufacturing sites in Taiwan and India, and with Amazon for AI-powered in-car experiences. Apple has been doing this quietly for years. The neural engine in their A and M series chips runs image processing, voice recognition, real-time translation, and all of it happens on one device. The 16-core neural engine in current chips runs at 38 TOPS. There's no cloud call, no latency, and from a privacy standpoint, your data never leaves your pocket. Then there are startups getting into genuinely different territory. Companies like BrainChip and SynSense are building neuromorphic chips, processors inspired by how the brain actually works, where computation only happens where there's something to respond to. The chip sits at near zero power consumption until a sensor detects something. For environmental monitoring or industrial sensing, where you need to always have awareness, but you can't afford always-on power draw, this approach is pretty radical. The common thread across all of these is a shift in priorities. The question is no longer how do we maximize performance at all costs, it's how do we get to good enough performance at the minimum possible energy. And in a huge number of real applications, good enough is more than sufficient. Now, let me give you a sense of the actual scale of what's happening here, because I think it is where most coverage undersells it. The edge AI hardware market sat at somewhere around $26 to $38 billion in 2025, and it's growing at between 17 and 26% annually depending on which analyst you look at. By 2030, projections put it close to $60 billion, and by 2033, some forecasts go past $118 billion. By 2036, the AI chip market for edge devices alone could exceed $80 billion. About 89% of smartphones sold in 2025 include dedicated on-device AI hardware. More than 150 billion edge AI devices are expected to be in use by 2026. Intel and AMD together shipped over 100 million AI-capable CPUs for PCs and smartphones just at Computex 2025. Microsoft's Copilot Plus program now requires at least 40 TOPS of on-device neural processing as a baseline certification requirement. The installed base of AI PCs is forecast to pass 100 million units by 2027. Those are not niche numbers. That's the mainstream consumer market moving all at once towards on-device intelligence. Now, I want to be really clear about something because I see the Nvidia is losing take floating around, and I think it's just wrong. Nvidia's data center business is past $50 billion a year. They dominate the most valuable part of the AI stack, which is training large models, and that is not going anywhere. Nobody is training the next generation of frontier models on a phone chip. The physics don't allow it. But what's interesting is that Nvidia is not sitting out on the edge AI story either. Their Jetson platform is purpose-built for edge and embedded AI, and in June 2025, they launched the Jetson Thor, a compute board that delivers 2,000 TOPS within a sub-100 watt power envelope aimed at level 4 autonomous driving. That's a real edge product for real edge use cases. They also have the Drive Thor and Orin platforms for automotive and robotics respectively. Nvidia accounts for about 39% of edge AI computing revenue already, largely through Jetson, with roughly 2 million developers building on that ecosystem. That is a significant software moat. CUDA lock-in is real. What's actually emerging is a layered system. Big training workloads stay in the cloud because they have to, but inference, especially real-time inference, is progressively moving towards the device. The cloud does the heavy lifting, the edge does the fast reading, and both grow together because the overall demand for AI keeps expanding. Okay. This is where I want to give you my honest read on this. I think that the centralized AI model was a necessary first chapter. You build the models in a place where you can throw unlimited power at the problem. You figure out what AI can do, and then you scale it up. That worked, but it was always going to be the first chapter, not the whole story. The more I look at this, the more I think the edge AI transition is not really about chips. It's about where intelligence lives. Right now, intelligence is centralized. It lives in server halls in Virginia and Oregon and Singapore behind cooling systems the size of buildings. Most people interact with AI through a thin client that basically just sends a request and receives answers. Now, what's being built right now is a world where the intelligence moves out to the edge of the network, into the car, into the factory, into the wearable, into the phone. The device stops being a terminal and starts being an autonomous thinking unit. And when you have potentially 150 billion of those things operating simultaneously, the aggregate computer power dwarf anything any single data center can offer. From a practical standpoint, this also makes more sense for a lot of applications. Lower latency, better privacy because your data stays in your device, resilience to network outages, lower long-term operating costs. The advantages are real and they compound over time. I'm genuinely excited about this. The edge AI market growing at 20% a year for a decade would be one of the largest wealth creations events in semiconductor history, and it's barely getting any attention compared to the Nvidia story. So, is Nvidia versus edge AI a competition? No. Not really. It's more like the next phase of the same story. The question to ask is not who wins. The question is, what happens when intelligence stops living in one place and starts living everywhere else?